welcome back to our channel, that is AI next generation. So today topic will be related to the gradient descent. So already we have just seen before 4 video, already I've just teach you about introduction to the deep learning, even layers in the neural network, activation function in the neural network, and even how a neural network works. Now this video will be only for the gradient descent in the neural network. What is the role of the gradient descent during the backpropagation time? Okay. So yeah, it is really most important topic, gradient descent. So before starting the topic of the gradient descent, why we are using gradient descent? The reason for the use of gradient descent is to minimize the cost function. So cost function already we have discussed in the previous chapter, or sorry, previous video. That particular whenever how you are just calculating the loss or the cost. So whenever it is basically difference between the actual and the predicted, that will be the difference between them, that is called as a cost function or a loss function. Okay. So what you are doing there, you are just calculating the loss, and that particular, if the loss is really high, then what you are just doing during the back propagation, you are just adjusting the weight. So how the weights are adjusted? With the help of gradient descent, you are able to adjust the weight. Okay. So gradient descent play a major role to adjusting the weights of that particular model. Okay. So because during the initial time you will assign a random weights to in all the features. Okay. But that weights will be not a fixed weight, because during the training time the weights will be updated. So why weights are updated means you will give more priority, more weightage to that particular feature, which is the most important feature to determine what the output it is. Okay. So what is gradient descent neural network? Already I have explained you. So thus now it is a the cost function. Whenever you want to optimize the cost function or minimize the cost function, you are using a gradient descent. Okay. So there are two methods you can use. I have just written one. You can just use for the brute force approach. So what does it mean? It's basically by the word you can just understand. Whenever you have 3 to 4 features. Okay. So in the input you will create a 3 to 4 neurons. Okay. So at that case you will just assign the more higher weightage. You know that particular feature is the most important feature. But whenever it comes 100 feature, 200 feature, even lakhs of feature, in that case you can't go for the brute force approach. Okay. So at that case you are using gradient descent. So gradient descent is really simple. It's only the main task is to gradient descent is to optimize the cost function and adjust the weight. Okay. And it works during the backward propagation when the model has been predicted something. Okay. This is how the gradient descent works in the during the backward propagation, and the main task is to of the gradient descent is to optimize the cost function. Okay. So how gradient descent works, I will just go through in the brief. So you can just gradient descent is always works in the convex function. Just remember, this is the most important point. Okay. So this is the convex function, what it is doing. So whenever you are just rolling a ball from this top of hill, so where it will be stop, it will just stop here. It will just first go here, then here, it will like pendulum, it will go, and then after that suddenly it will stop here. Why? Because at that case the ball will be stopped. So at that case you will have minimum cost function. So this acts the same way as the gradient descent also works. So this you can just think this is the slope is the negative slope. Okay. So it will just go down the hills. Okay. Then after where it will just stop, whether it will just stop at that case where the gradient, or you can just say slope is just 0, at that case it will just stop. So we are just plotting with the cost function with respect to the weights of that particular model. Okay. So this is the what we are just plotting this particular graph. Okay. So what you are just doing, you are just rolling a ball from top of hill, and where the slope is 0, at that position it will just stop. So it acts like the same concept, where whenever you have particular gradient descent. Okay. So gradient descent where the slope is 0, at that case you will say that at that case that will be the base weight. Okay. So how the weights are changing, how we are just updating the weight, we will go through in the detail more. So it is on the previous one only. Whenever you are just rolling the ball from here, it will go first here. Okay. Then after it will goes from here, and then after it will stop somewhere here. Okay. So at that position the slope is equal to 0, at that case it will just stop. Okay. So this is how gradient descent also works. Gradient descent find the more optimal weight. How they will find the more optimal weight? whenever you have minimize the cost function, it you have to update the weights, and to update the weight you are using gradient descent. And gradient descent, what it is doing, it is just acts like when you are just giving the positive slope and negative slope on the basis of the slope, which direction it should move, whether it should add on that particular weight or whether it should be subtract on that particular weights. Okay, so this how gradient descent or works. So again I will give you in the more detail. This is the graph of that particular gradient descent, you will able to understand. So here already I have just written the same thing, the base algorithm that is used to minimize the error with respect to the weights of the neural network. Okay, so here already we have discussed about this thing many times, and there is also one concept, that is the learning rate. Okay, so learning rate, what is learning rate? Learning rate is basically how fast your model is learning. You are just giving something learning rate, and how fast the means you can just directly say how the learning rate determines the step size of the update used to reach the minimum. So it's basically say how fast your model should be learn, so that it can go to that particular position, this position. At this position you can just say the weights is the minimum, it the sorry, the cost function is the minimum in this particular case. Okay, so whether you will add on that particular weight or whether you will subtract on that particular weight is depend upon your slope is a positive slope or your slope is a negative slope. Again I will explain you. So gradient descent, whenever see it's the same concept, whenever you are just rolling a ball, so at this position cost will be the minimum, so you are just see jw with respect to that particular weight. So this is the important graph, you are just plotting a graph between the cost function with respect to the particular weight. So you are just differentiating cost with respect to weight, means how much you are just adjusting the weight, that amount of cost is changing, whether it is going minimum or it is going up. Okay, this is how they are just looking in the back propagation time, means during the updating of the weight. Okay, so this is basically called as a global minima. We are just calling this position as a global minima, means inside that you will only have the one global minima position. Okay, at that position you will have cost will be very very minimum. Okay, so even I have explained you about the learning rate, even about the learning rate. So how much we have to take the learning rate, again we will discuss in the next slide. So here just understand the basic. To minimize the error we have to change the weight, that is the main formula. And to by the and how we are changing the weight, with the help of gradient descent we are able to change the weight. Okay, so now you can just see this is the negative slope and this is the positive slope. Okay, so this is the real formula of gradient descent, minus of derivative of cost function with respect to particular weight. Okay, so whenever your slope is a negative slope, then what this is the real formula how the weights are updated. This is the w new, the black one is the w new, this is the w old, what was old weight, minus learning rate you have to provide into gradient descent. Okay, gradient, this is the gradient value. Okay, so learning rate, basically what you are just saying, learning rate is basically how fast your model is learning, that is the really important concept. Okay, so how much you will provide the learning rate, we will see in more about the learning rate during the coding time. Okay, so learning rate is basically in the case we are just giving standard as 0.001. So you can't give learning rates more, you can't give learning rate big, or you can't give learning rate small. Okay, so main reason is that whenever you are giving high learning rate, means so it will not come in this position, it will just go this way, this way, this way, it will fluctuate from this or this position only. Okay, so it will never reach to the global minimum position, but your main task is to reach to the global minimum position. At that particular position your cost function is minimum. Okay, so you can't take a really big learning rate like 10, 100, 2000 or 1000, 1 lakh. Okay, so and the things is you can't take even a small learning like 0.0001. If you will take, then it will take too much time to come into the global minima position. Okay, so your main task is to reach to the global minima position, but how they will just read, you can't take big learning rate, and even you can't take a small learning rate, it will take too much time to converge to the global minima. Okay, so that is the standard, we are just taking 0.01 or 0.00001. This is how we are just moving. Again we will about how much learning rate we are taking, and we will see different learning rate in the coding part, and how we are just giving what are the outputs. Okay, So this is the basic about the learning rate. So how weights are updated, it's really important, you should know. So already I explained you, this is w new equal to w old minus learning rate into gradient. Okay, so w old is basically the old weight. Okay, you and w new is the sorry, w old is the your old weight. Okay, and this is the basically what the new weight will come after updating the weights. Okay, so learning rate will be the fixed for all the different, because all the weights, because you are just giving constant value, you are just multiplying with the constant value. Only the gradient will be different for different weights. Okay, so what you are just giving it, whether your slope is a negative slope and positive slope. So by default is formula is derivative of loss with respect to particular weight. Okay, so whenever you have negative weights, means you want to, your main task is to reach to wi position. Okay, at that position your cost function will be the minimum. Okay, so whenever, then what you will do, you will add the weight, because this is your wi. Okay, you can just understand this is your initial weight, and to reach to that particular you have to add something. Okay, so that's why w new will be become what was the previous weight plus add of learning rate into gradient. Okay, this will be the w new. Similar about the positive slope also. Whenever in the positive slope, what you are just doing, your main task again, you have to come to this position. So in that case you have to subtract from that particular weight. Okay, so to subtract that particular weight, what you are just doing, this is your initial weight. Okay, this is your initial weight, and you have to reach to this position. Okay, so for to reach this position, you have to subtract from this particular. Okay, so w equal to w new equal to w old minus gradient into gradient, learning rate into gradient. Okay, this how this formula goes on, and from there how the weights are changed during the backward propagation. This is the really important concept. Okay, so I will go again our brief about, I will just over means now I will just complete this video and brief about the gradient descent. So gradient descent is a really famous optimization technique. Okay, it technique and used in the both in the machine learning also and in the deep learning also. Okay, so the main purpose of gradient descent is to minimize the cost function. To minimize the cost function, you have to update the weight, and how weights are updated you already seen, whether your slope is the positive slope or the negative slope. Okay, and global minimum position, you have to reach at that position, your slope will be 0, and that particular will have the cost will be the really minimum, you can just say. Okay, so now even you can just see how we are just calculating the cost. We already have seen why it's basically the mean square error we are just finding. Okay, so a lower you already know the lower the cost function means your lower the prediction, lower the difference between the prediction and the actual value, means your what the model has been predicted, it's match approx to the actual, that your model is performing really good. Okay, so there are three type of gradient descent we will look in the next video. What are stochastic gradient descent, what are batch gradient descent, and what are mini batch gradient descent. Okay, these three is really often we are just using. Stochastic gradient descent we are using most often. Okay, so this was the brief concept about the gradient descent, how gradient descent works. Okay, and everything related to the gradient descent, and gradient descent works only in the back propagation, and the main task is to update the weights. Okay, so that's all for this video. Hope so if you like this video, please subscribe our channel. So in the next video we will go through the all the loss, different type of loss function in that particular neural network. Okay, so that's all for this video. Thank you.